If you're watching this video, you are probably very familiar with Comet 3I Atlas. It's hard to escape all of the information that is out there, and for good reason. It is a very weird object, unlike anything we have ever seen here in the solar system. Atlas is only the third confirmed interstellar visitor entering our solar system. Its trajectory cuts across our planetary neighborhood on a hyperbolic speed, making it a fleeting yet invaluable messenger from beyond. Initial observations have teased a strange and unique composition, including a coma overwhelmingly dominated by carbon dioxide, text, CO_2 gas, $text, CO_2 to text, H_2 text, O ratio far above what typical comets show, and a dust environment colored by complex organics and irradiated ices. Until now, most of the scientifically significant images and data came from Western or multinational telescopes, Hubble, JWST, the Gemini network, and the VLT. These instruments provided the critical phototitric curves, morphological evolution, and compositional spectra that shaped our emerging picture of 3I Atlas. But suddenly, a perplexing gap has opened. Several of those key Western telescopes are reportedly offline, facing maintenance, scheduling constraints, or technical downtime, leaving a silence in the astronomical community. In that vacuum, China has quietly dropped a bombshell on the astronomical community. Fresh, high-resolution images of the interstellar comet have surfaced from Chinese observatories, filling the observational gap and in some ways leaping ahead. The timing couldn't be more telling. The released Chinese images are not casual snapshots. They come from observatories equipped with ultra-wide, high-resolution cameras capable of deep-field imaging, capturing both the comet morphology and background stellar fields with stunning clarity. Observers in China are now offering fresh frames of the coma, potential tail structures, and dust plumes at the exact moments when Western facilities are dark. This sudden shift awakens critical questions about observational equity, data access, and the geopolitics of astronomy. This transition has multiple profound implications. First, the scientific opportunity is immense. The comet is evolving rapidly as it approaches perihelion, with its outgassing and dust-to-gas ratio shifting moment by moment under solar radiation pressure. The observations made by any party in these interim periods are precious, enabling continuity in mapping how 3I Atlas changes over time. For Chinese astronomers, the ability to fill these observational gaps gives them a powerful, temporary role in constructing the comet's definitive story. They are now offering fresh visual evidence, hints of faint jetting, an elongated halo, or a subtle asymmetry, that may become the essential reference points in the morphological timeline. Second, the control of images means influence over interpretation. Whoever publishes critical data first often shapes the scientific narrative. Chinese images might emphasize features, morphological interpretations, or anomalies that guide subsequent work. In a competitive scientific ecosystem where reputation and citation matter, early and exclusive access to critical frames gives Chinese teams a significant boost. They may in time take the lead on compositional or dynamical models of 3I Atlas. Third, there is the matter of scientific sovereignty and access. While many Western observatories operate under open data policies, as Beijing's space science infrastructure grows, the decision to release or withhold data can become a tool of soft power. Conversely, the open sharing of Chinese imagery is vital to democratize the science, but this depends entirely on transparent release policies. Fourth, the optics of perception and prestige cannot be ignored. Releasing key images at a moment when Western telescopes falter enables China to showcase technical prowess, capability in deep space monitoring, and leadership in frontier science. The media narrative that China saved the day when others went dark resonates powerfully, especially in a field intertwined with national standing. This episode also critically highlights the fragility and unevenness in global astronomy infrastructure. For decades, priority access to large telescopes was concentrated in Western institutions. But as capabilities become more distributed globally, the old paradigm cracks. A single nation with modern, capable facilities can now punch above its weight in major discoveries. And yet, this shift raises critical questions for the global community. Will the global community be allowed full, timely access to raw data so that independent verification is possible? There is the inherent danger of over-interpreting limited data. Missing spectroscopic or concurrent multi-wavelength observations could leave critical gaps in the understanding of the comet's chemistry and thermal dynamics. From the vantage point of the broader astronomical community, this turn of events is a wake-up call. No system should depend too heavily on a single set of observatories. Diversification, encouraging more global observatories, becomes imperative. The Chinese move illustrates a potent truth. Those who build and maintain capable infrastructure and are nimble enough to pivot can step into crucial gaps and profoundly influence the direction of discovery. The 3I Atlas case likely amplifies competition around future interstellar objects. The risk of telescopes going offline cannot be assumed away, demanding an expansion of time domain networks and coordinated global alerts. The drama around telescopes going dark is also symbolic. It underscores that science is not immune to infrastructure constraints, funding cycles, or logistical setbacks. In contrast, flexible, well-funded national observatories in rising powers can sometimes operate with an agility that established Western institutions cannot always match. The core tension is dramatic. The universe offers no repeats. Comet 3I, Atlas is a traveler, a relic of a distant system passing briefly through our realm. Its journey is unalterable by human ambition. Yet in that brief moment, humanity can choose how richly to observe it. The fact that Chinese observatories have seized this moment when others faltered feels almost inevitable, a stark demonstration that in the domain of space, capacity begets opportunity and stewardship. Imagine future history. Decades hence, scientists piecing together the properties of 3I, Atlas may look back on this moment as a front-line pivot in astronomical power. Did China's images unlock a new morphological finding? Did they localize an unexpected jet or reveal critical asymmetrical dust flows? If so, those frames might become part of the canonical record, and the teams that supplied them will gain lasting credit. The images from China now hold some of the most current keys to the comet's secrets, adding both drama and urgency. This is a turning point, not merely a curiosity in the annals of cometary astronomy. It signals a fundamental recalibration in who watches the skies, who publishes breakthroughs, and how the global scientific theater is orchestrated. The data is only the beginning. The politics, the prestige, the alliances, and the reactions all ripple outward. What emerges from this moment will shape not just how we understand 3I, Atlas, but how humanity watches beyond.